Welcome back to part 2 of the topic 7 assessment practice. So we are on number 4. And number 4 says, determine if each number is prime or composite. Then write all the factors for each number. So first of all, we've already established that a prime number is any number that only has two factors, one and itself, and a composite number has more than two factors. So what I'm going to do is I'm going to, over here on the right side, I'm going to draw two T-charts, one for 19 and then one for 33. And we're all going to pretend that Miss Barton has excellent handwriting when it comes to using this, right? So let's start with 19. What are the factors of 19? We already know to start with we have 1 and itself, right? So 1 and 19. So can we multiply 2 times anything to get to 19? No. What about 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, or 18? No. So the only factors that 19 has is 1 and itself. So we know that 19 is what? A prime number. Good. So now let's look at the number 33. So we know one factor pair is going to be 1 and 33. Okay. Is 2 a factor of 33? No, because 33 is an odd number and it is not divisible by 2. What about 3? Yes, 3 is a factor of 33. 3 times what equals 33? 11. Good. What about 4? Is 4 a factor? Please use normal voices. Is 5 a factor? 6, 7, 8, 9, 10, 11. 11 is a factor of 33. So can we stop trying to look for factors now? Yes, we have all of our factors. So 33 has 4 factors, which means it's what type of number? Composite. It's composite, right? So I'm going to draw my text box down here, and I'm going to type it in that 19 is a prime number, and we said that 33 is a composite number. Now, I've already written my factors over here on the right side of my screen, so you guys will just also list those somewhere on your workspace. All right, let's move on to number 5. It says, select all equations that have a dividend that is a multiple of 4 and a quotient that is a factor of 18. Now, when we look at this, it's kind of a lot. So what I recommend that we do is we break this problem up and we go step by step. So first of all, we need to decide which of these 5 equations has a dividend that is a multiple of 4. We know that a dividend is the large number, right? That is what we are dividing up. So these oh, you can't really see that. Hold on. Let me change colors. So these numbers here are our dividends, okay? So we need to decide, are those numbers a multiple of 4? Meaning, can we multiply 4 times something and get to these numbers? Is 8 a multiple of 4? Yes. Yes. Is 18 a multiple of 4? No, we cannot multiply 4 times anything to get to 18. So that tells me that this whole problem has to be out because it has to be a multiple of 4, right? So let's move to the next one. Is 36 a multiple of 4? Yes. Yes, we can multiply 4 times a number and get to 36. What about 48? Is 48 a multiple of 4? It is. I know that 4 times 10 is 40, and 4 times 11 is 44, 4 times 12 would be 48. So yes, 48 is a multiple of 4. Okay. Now let's look at 16. Is 16 a multiple of 4? Yes, we could do 4 times 4 equals 16, right? So we know that these 4 here could be our answer, but we're not done. So let me change the color of my pen, and now let's do this. Now, the quotient has to be a factor of 18, okay? So this is the quotient, right? The quotient is our answer in a division equation. So we need to decide, is the quotient a factor of 18? So can you multiply 2 times a number to equal 18?
Yes.
Yes. That means that this entire equation is true. 8 divided by 4 equals 2 fits both of the criteria here. Let's look at this next one. Can you multiply 12 times anything to get to 18? No, we can't multiply 12 times something to get to 18. So we know this one can't work. It's a no-go. We're going to exit out. Let's look at this next one. Can you multiply 6 times anything to get to 18? Yes, we can. We can do 6 times 18, which means that it is a factor of 8, and it has a multiple of 4. So this equation meets both criteria. Let's look at the last one. 4. Can you multiply 4 times anything to equal 18? No, you can't. So that means that this equation does not meet both of the criteria. So the only 2 that you should have circled would be these first, oh my goodness, what in the world? I don't know what I did. Hold on. The only 2 equations that you, I know, I'm trying, that you should have circled would be these first 2 right here. Okay? So let's move on to the next page of our practice. All right, so number 6. Number 6 says write 3 multiples and 3 factors for 24. Now, it's not asking us to list out every single factor for 24, and it's not asking us to list out every single multiple of 24. Just list out 3, right? So we know, let's start with the multiples. We know that when we list out multiples, it's basically multiplication problems, right? We're looking at skip counting. So we could start with 24. Is 24 a multiple of 24?
Yes.
Yes, it is. 24 times 1 equals 24. What about 24 times 2? Yeah, and that's what we're trying to figure out, right? So I could come over here to the side and oh my goodness gracious, Miss Barton. We could do 24 times 2. I know that 2 times 20 is 40. 4 times 2 is 8. So 40 plus 8 equals 48. So this is the next multiple in my group. So I have that. Now I could do 24 times what?
3.
Yeah, 24 times 3, right? It's okay. So 24 times 3, we could do 20 times 3, which is 60, plus 4 times 3, which is 12. 60 plus 12 is 72. Okay, so our next multiple in our set is going to be 72. Do I need to continue to list out multiples? No, I've already listed the 3 multiples that I needed. So I can erase this over here. And now I need to list out some factors of 24. Does it tell me to list out all factors of 24? No, it does not. It only tells me to list 3 factors of 24. So we know that one factor pair is going to be 1 and 24 because every number has the factor pair 1 and itself. But what Could be another factor. Is 2 a factor of 24?
Yes.
Yes, 2 is a factor of 24 because 24 is an even number. Any even number is divisible by 2. Can I stop here?
Yes.
Yes, it does not ask me to list out 3 factor pairs. It does not ask me to list out all of the factors. It just says list out 3 factors of 24. And that is what we have. So we can stop here and we can move on to number 7. So number 7 says, write 2 multiples of 3 that have a factor of 7. Use equations to explain. Now this one sounds a little tricky because we need to figure out what multiples of 3 also have a factor of 7. So what I'm going to do is I'm going to, right over here on the side, I'm going to just list out some of the multiples of 3. Okay, so we have 3, 6, 9, 12, 15, 18, 20, 21. Oh, look, I noticed something about 21. Does 21 have a factor of 7?
Yes.
It does. Yes, we could do 3 times 7 and it would equal 21. So when it says use equations to explain, all it wants you to do is pretty much just say 7 times 3 equals 21. Okay, because that's an equation. It shows us that one of the multiples that we're looking at is going to be 21. And then there's going to be one more that we have to figure out, right? So let's keep going with our multiples until we can find another multiple that also has a factor of 7. Okay? So let's keep going. So we're at 21. What would be next? 24, 27, 30, 33, 36, 39. Does 42 have a factor of 7? It does have a factor of 7. So 42, what is the factor pair for 42? And like that would include 7. 7 times what is 42?
6.
What is it?
7 times 6 is 42. Yep, 7 times 6.
7 times 6 equals 42. You are exactly correct.
Miss Barton,
Hmm?
where do we put the...
This is where we will end part 2 of our topic 7 assessment. So stick around and get ready for part 3 coming up next. See you soon.